All right, in today's assignment we are going to study 6-2 histograms. So we're going to construct histograms. We're also going to identify what a 5-number summary is and determine when we have to use those numbers to describe our distribution or when we use the mean and the standard deviation. So a histogram, this uses bars to display numerical data that has been organized into equal intervals, and the intervals come from here. In this case, the interval would be 20 hours, or 20, it says percent. So we would say 20%. So in each of these it represents there's 20%. So 0 to 19 is the first 20%. 20 to 39 is the second percent that we would list. And then these show the frequency at which they occur. We also have what's known as a frequency table. This shows how many times data will lie between specific intervals. So you'll start out by listing an interval from 10 to 19, and you'll find out how many times either the number occurs or whatever it is that you're looking at occurs. So in your list of numbers, you're looking to see how many times they occur. Example 1, it gives you a frequency table and asks you to draw a histogram. So it already tells you the intervals right here. So when we create our histogram, we're going to break this up into intervals that it already tells us about. And here it tells us the first one has to be from 1 to 7. The second one is from 8 to 14. The next one is from 15 to 21, from 22 to 28, and the last one from 29 to 35. Then we will use the frequency to draw our graph. So I go from 1 all the way to 8, so you could go by ones here. 1, 2, 3, 4, 5, 6, 7, 8. So our first one says it has 5. In our second interval, there's only 1. In our third interval, there are 8. In our fourth interval, there are 2. And in our last interval, there are 4. And I like to shade these in. Shading is not required. And that would be the histogram for that set of data. So some definitions. We have measures of spread. We have talked about different things. Earlier we talked about mean, median, and mode, and those were measures of central tendency. But now we're going to talk about measures of spread. And this is used when two very different sets of data end up having the same mean. This is just a way that we can describe how widely the data values vary. So our measures of spread include the range, and the range is the difference between the greatest and the least value. It includes the quartiles, and what quartiles do is they divide the data into 4 different groups from least to greatest. So you have about 25% of the data in each quartile. The median will divide the data into the upper and lower halves, and then you get what's known as the lower quartile and the upper quartile. The lower quartile is the median of the lower half, and the upper quartile is the median of the upper half. A 5-number summary is when you include all 5 of those values we just talked about. The least and greatest values, so that's the first one. And that's the second one. The lower and the upper quartiles, the third and the fourth, and the median would be the 5th. Standard deviation is a value that shows how the data deviates from the mean of a set of data. If the graph is symmetric, this is really important, then we will state the mean and the standard deviation. If it is skewed, then we will list the 5-number summary, whether it's positively skewed or negatively skewed. Okay, I have a graph here of a normal curve. And we talked about this as being symmetric. And And here we talked about if it is symmetric, then we know the mean, median, and mode all line up right in the middle. And standard deviation is a number that we're going to find that enables us to include 68% of the data. So if we add this number to our mean, we'll call it the mean even though they should all be the same. If we add it to our mean, or we subtract it, if we add it we go this direction, if we subtract it we go this direction. So if we add those values to the mean, then all 68% of our list, whatever they might be, should fall between one standard deviation away. So we call that one standard deviation positive. This is one negative standard deviation. All the way to this next line right here is 95% of the data. And we say that 95% of the data will lie within 2 standard deviations away, whether it's a positive or a negative distance. So I'm not expecting you to completely understand that, but we are going to find standard deviation. We will apply it later. So we will be looking for mean and standard deviation if it is symmetric. If it is not symmetric, then we will be looking for the 5-number summary. So on example 2, you're going to describe the center and spread of the data either using the mean and standard deviation if it's symmetric, or the 5-number summary if it is not. So we're going to justify what we chose by constructing a histogram with these values. Now we have done this already previously, so remember that you have to put these numbers in a list and then use your stat plot and construct a histogram. So when I put these in my list and I graphed them in a histogram, it looked roughly something like this. So as we look at this, we would say that this is not symmetric, that it is skewed, and we would actually specifically say it is positively skewed. And because it's positively skewed, or even just skewed, let's write positively skewed, or at least positive, then you need to find the 5-number summary. I'll just abbreviate it. I ran out of room there. So to find the 5-number summary, you're actually going to use your calculator today, and then I'll teach you later how to do this by hand. So to use our calculator, we press statistics, and across the top you have edit, calc, or test, and we want to calculate something, and the first one is a 1-variable statistic. We have 1 variable, so we press enter. It takes us to our home screen, and then we press enter again, and it gives you a whole list of numbers. And down at the bottom, the last 5 numbers will tell you the least value is first, and in our case we could have actually picked this out from our set, is 5. Then it's going to tell you Q1. Q1 is the lower quartile. The lower quartile is 22.5. Then it'll tell you the median is 36. Your upper quartile, which is Q3, is 48.5. And then your min, your minimum value, or your max, your greatest value, is 95. And again, you could pick that out pretty easy by looking at your list. But these other 3 do require some lining up of your variables and finding out how they divide into quarters. So if it is symmetric, you will find the mean and the standard deviation, and you'll do it the exact same way, except that when you press your 1-variable statistics, if you see an X bar, it'll be your first number, that will be your mean, and your SX will be your standard deviation. So again, I will show you how we find those. We know how to find the mean already by hand, but I will show you how to do standard deviation at a later date. Okay, on example 3, you're just going to use this information. It says the histogram shows how many hours per year a group of teens said they spent volunteering. How many hours did most of them volunteer? So as you look at this, it says the number of hours. It says that the majority right here had 35 hour, or had 20 to 39% of hours 35 times. So we are going to say 35 was the average. So hopefully that will help you with your 6-2 histograms.